Hello everyone, welcome to Card Pro Marks. Here in this session, we will cover 3D tolerancing and annotation in 3D experience platform. Okay, so before enter into 3D tolerancing and annotation, I am requesting you go to the previous video so that you can get the concept of 3D tolerancing and annotation from the very basic level. Okay, so here in 3D tolerancing and annotation, the rules is very simple. Like uh, here, our main aim is to create the model based on the definition strategy, like 3D master, allow collaborative work, standalone role to create product definition, and also can purpose to an engineering designer. Then the model based designer through a fast 3D tolerancing. Here in this by use of a 3D experience platform, we can cover complete product definition through 3D annotation. No need to go for a drafting to create a separate annotation. Here in 3D itself, we can assign the annotation, we can give the datums, we can give the dimension, we can give all the datums features related, and it is standard complaint schematic information like your ISO standard, ASME standard, JIS standard. You can follow by using the platform. The main advantages of this 3D tolerancing and annotation is reduce the decision time using concurrent engineering. Okay, it will reduce the time period to analyze the tolerancing activities. Let's suppose you want to create, you want to manufacture some product. At that time, it will take. You will do the design, then you will convert that design into 2D drawing and give some annotations and dimensions. That time it will take more time. So by use of a 3D tolerancing and annotation, we can reduce the time. Okay, then we can provide 100% 100% product manufacturing information in 3D for accurate and annotated geometric definition. Then design in compliance with the regulation and standards, reduce the tolerancing and drawing interpretation error. Okay, so while converting in our regular method, if you want to convert the product, convert the 3D part into 2D drawing, that time some error, that any discrepancy will happen during the conversion. Maybe sometimes it will happen. Okay, so the by use of this 3D tolerancing and annotation, we can reduce that error also. Okay, the process is very simple. First thing is we need to design the product. In the design itself, we can obviously that part will attach to the assembly specification. Then we can go with the we can give the we can add a definition and dimension and tolerancing, and we will match that dimension and tolerancing into the assembly. Then validate the annotation, then generate the 2D representation and a drawing with without means we can create the 2D drawing also from the 3D annotation. Whatever the dimension we are giving in the 3D, that we can convert into 2D drawing also. And the next is after converting or generating the 2D representation and drawing, we can review the annotation by using the 3D plane. Okay, in 3D annotation itself. So So the thing is, what we are covering, what we will cover in this session is, first is we will create annotation view. It's nothing but creating the view in 3D, in 3D itself. Okay, like front view, top view, side view, auxiliary view, section view. All these view we can create by using the 3D annotation toolbars. Okay, you can find this thing. If I will go with the 3D tolerancing and annotation app, then here you will find the view layout. In this view layout you can see there are the principal view. Here you will get the principal view. By default it will go with the front view. Then if you want to create at a time with the top view, left view, right side view, bottom side view, then rear view, you can select, check on all the option and create the view at a time. Then after that, view from reference. In the view from reference you will get the first one is front view. It is nothing but if you want to create the view from the reference element, then the front view. Then here you will get the section view, section cut, then auxiliary view. Similarly you will find offset section view, offset section view, offset section cut also, align section view, align section cut, view from layout. Okay, so the first thing is we will create the view. Okay, so as I already said to you, we will define the annotation or dimension from a part which is attached to the assembly. So I will go with lower a with new one. Okay. This is my part. I want to create the I need to give some annotation and dimension in this part. So the first step is, first I need to create the views. Okay, all the views here I want to assign the annotations. So for view I have principal view. So here automatic the bounding box is created while click on the principal view. So by default it is taking as front view, but I don't want the bounding box will be this much of size. So for that what you need to do is you need to assign the plane, bounding box plane. So now you can see I assign the bounding box plane is Z-axis. You can see here Z-axis. I want this side is my front view. Okay, you can see the arrow mark of a green arrow mark, that is my front view. Okay, so I assign here Z-X plane and this is my front view. Click OK. Now you can see here the annotation set is created. Capture front view is created. Automatic front view is created. Okay, now I exit with the front view. Now I will go with the view from reference. So if you want to learn what is all the views and all, you can go to the previous video so that you can get the idea how you can create the views, different kinds of views. Okay, there I explained very well. You can follow the previous video. So here I can go with the view from reference. Now my reference is this one. So I will take the reference as a top view, and here I can write here top view. So go to the properties, here view as top view. Okay, now you can see front view, top view is created. Front view, top view is created. Okay, now I will go with the auxiliary view. Align section view. So align section view, I can use the predefined sketch here. If you don't hide this one. This is the sketch here. So I will use this sketch as a align section view. Okay, you can see line section view is created. Okay, now I will exit it. The first step is created. How we can create the front? We can create the view in a part. Now the second step is we will create the datum. So give the annotations. Add the annotation in the part. So next one is tolerancing advisor. So this tolerancing advisor, so what I need to do is I will select this one automatic in this schematic. It will select it will propose you what kind of features you can add in that particular surface or particular features. So here I can give as a datums A. You can see datums A. Okay, click. Okay. Now you can see the front view itself. I am sorry. The front view I need to create the datum A. So if you want to work on front view, so what you need to do is you don't need to double click to activate the front view. You need to double click to activate the front view. You can see the underline mark, so that you can see I want to create the datums in front view. So here tolerancing advisor, and I will select this one and go with the datum switcher. You can see datum A is created. Click OK. Now you can see this position, this annotation position is slightly different. So what you need to do is you can go with select that annotation and go to the properties to change the properties. On go to the text. Here it is horizontal, so I can go with the fixed angle. Okay, 0. Sorry, vertical. Okay. Here I can go with the fixed angle minus 90. Okay. In this way, here you can apply all the properties as per your requirement. Here you can apply all the properties also. If you want to go with some font size, styles, size, then text different means frame, square or rectangle, color, thickness, everything you can change here. Feature properties, manufacturer. Okay, so click OK. Now the first step is completed. Now I can go with, I can give the dimension here from this to this, this surface, and press control, select the second surface. Automatic it will propose you some features command, geometric tolerancing and annotation creation commands. So I can go with the distance one, and automatically this one is created. Here you can find the limit of size definition, how what kind of dimension you want. So if you want to tolerance in the auxiliary dimension means like this reference one, and then general tolerancing means only general tolerancing. Here you can define the ISO standard or minimum maximum, then upper maximum limit, then ISO 286-1 tolerancing class, then unilateral limit means maximum or minimum limit you can and then specifiers, then modifier, all these things. Then here in this deduction feature also you will find the pre-stated condition, statistical tolerancing. So I will go with the general tolerancing only. So because I want only the dimension. Click OK. Now you can see it is created. The dimension is created in front view. So similarly, I can go with the tolerancing and advisor this surface and the top surface. By press control, here you will find the dimension and that is 45. You can see 45. The same as the tolerancing. Click OK. Now I will switch to top view. Now you can see I activated the top view. Then here tolerancing advisor. Here this one let I will go give them datum B, datum B, and this one is datum C. I feel this pain, you already know. Turn that to gains, let my money show. Okay. Now you can see what I did in the front view. I have given one datums. In the front view itself, I have given the dimension, normal dimension from bottom surface to the top surface and the very bottom surface to very top surface. Okay. Now we will give the dimension of this one. Now here I have given the tolerancing advisor here. I need to create the datum feature. Now you can see here in this tree structure itself, you can see here. And the things I could be, I just wish I had seen. I feel this pain, you already know. Turn that to gains, let my money show. I've got these things that I can't let go. Watch me turn this life into something that you can never own. Now in the tree structure you can see the datum features A, B, C, dimension, 2 dimension we have given and the 2 modes are given. Okay, so here I will define the datum feature. Can datum feature 1. Okay, so here datum is added, demanding datum feature B and datum feature C. So now I have defined the datum feature, datum system A, B, C. You can see the datum system A, B and C. System A, B, C. I defined it. Okay, now with respect to this datum features, what I need to do is, what I will do is go to the advisor and select the cylindrical one, and here you can find the all, you see, select all the same diameter parallel cylinder if at least one cylinder has a coplanar edge with one of the edge. Okay, so if I will select this one, automatic whatever the same size hole or same size hole is there, that will be selected. Okay, if it is in same planar. Okay, now I can define as a number of 1 and go with the ISO tolerancing. See here. Okay, now you can see 3 1, then click OK and define now you can see 3 number of a hole and diameter is 55 and I have given the termination limit of size. So here I will go with the datum C, select this one. Okay, datum C, and here I can go with just a second. Now the whole dimension is completed. Now we will go with this slot. Okay, for that what I need to do is go to the tolerancing advisor, then select this surface and select the surface by pressing Ctrl, and here you can go with this distance creation. Okay, distance creation, but this time I will go with the this upper max and lower max deviation limit. Click OK, and here I can add datum C. With respect to datum C, it will be calculate, and that way perpendicularity numerical value, the tolerance gauge is 0.1 with respect to C close. Okay, and you know how to define this what you need to do is select this one and select this tolerance, go to the annotation, here automatic grouping, so automatic group will create. Here you can define, you can change this one also, annotation position. Similarly, you can go with the next one, that is datum C. Now you can go with the auxiliary view. Double click here, auxiliary view. Auxiliary view. Okay. Now here in this auxiliary view, we can create a datum, that is datum D. Annotation set, tolerancing, created T, click OK, and here you can add the datum as D, because you need to define the datum system. Okay, datum D is created. Now I can define tolerancing, this one and these two, the dimension, and which is parallel to D, which is parallel to datum. Click OK. Now you can see the datum A, B, C, D is created. Okay, so I forgot to create another one, that is in top view. You can activate this. I can give another dimension, that is angle also. You can see here, you can give the angle, you can repositioning the angle according to your need, and this time I will go with the general tolerancing. Click OK. This is how we can create huge datums, dimensions, and datum switches, data systems. Now I want to create the captures. So in this view you can see automatic front view and auxiliary view has created some captures, but in top view it is not created the capture. So for creating the captures, what you need to do is go to the display view. You need to arrange all these things properly. See the display, this is the front view. Actually this is the front view. Now in the front view itself you can go with the, here click on this, and here it is uh, captures, display captures. So automatic the front view is captured in captured. So what is the advantages of capture is, in this front view whatever the thing you have given, that will features in the front view. Okay, and let go. If you want to create the captures in the top view, then display the top view. Now you can see this is all the dimension, it's in top view, and I want to create the captures. So here it is display view, and here create the captures as a top view. So what is the benefits of this? See, no need to, simply go to the one in a single click, no need to click on this. See, in a single click, no need to go with the front view and display of front view. Simply you just go on the top view, display the capture, automatic it will come. Auxiliary view, display the captures, auxiliary view will come. Front view, display the capture, front view will come. So this is the advantages to, if you want to create, if you created the captures in 3D launching and annotation app. Hope you got the concept how to create the views in 3D experience platform, how to add the annotation and the dimension in the part, and how to manage the capture whatever the view you have created. Hope you got some concept in this session. Thank you. Jai Jagannath.